Alright guys, welcome back. This is 4.4 Continuous Exponential Notebook. So, a continuation of your exponential functions, okay? So, the warm-up, 4.4. Decide which plan is best. So, which one is the better plan? So, let's take a look at A. Okay? You have $1,000 and it's increasing by 2.5, which is the same as over 100, which is 0.025. And it is quarterly, so your N is 4, 4. Okay. And we'll just pick for 1 year and see which plan is the best. Sounds good? All right, so we're going to type that in, and we are going to get the following. Clear. Put that up. $1,000 increasing at 2.5%, oops, divided by 4 because it's 4 quarterly, raised to the 4 times 1. We'll just say per year. So for this one, you make $1,025.24. Okay? Let's take a look at B and see what B is. You got $1,000 increasing at 3% per year. So you could put divide by 1 times 1. Or you could just use the other formula where it's just raised to that 1. Your choice. Okay, so let's look at B. 1,000 increasing at 3% raised to the 1. And that comes out to be $1,030. So which one do you think is the better plan? I am going to pick B because I made $5 more, almost $5 more. Okay. All right, make sure you submit that online and get that turned in. Next part, 4.4. This is the last of our exponential functions. We are going to learn the word continuous exponential equations. So your objective today, students will be able to determine Euler's, it's pronounced Euler's, number and use continuous formula to determine its value. So let's go back and review a few things. So first of all, you have learned the exponential formula. Sometimes we do x, sometimes we do t. And this is the basic formula. And then you learn compounded, okay? Which is basically the same formula, but then it occurs however often per year. And there's that formula. Remember, x and t is the same, okay? And sometimes you may see it written like this. Instead of y and an a, you have the capital A and a P for principal. It's the same thing. So today you are going to learn continuous, because not everything occurs for 1 hour and it stops, another hour and it stops, 30 minutes and it stops, or 1 year and it stops. Not everything occurs like that. Some things occur continuously. All right, so that's called Euler's number that we're going to use. So let's take a look what that is. Okay. Oh, that looks kind of blurry to me. Let me go back and reread this. Refocus real quick. All right, that's as best as I can do it. Sorry, guys. So there's in fact a limit to how much we can accrue interest for each percentage, even if we can continuously compound the interest. So you don't want to keep going half a second, millisecond, and all that. That limit is found with a number known as Euler's number, and that number is the number E. Kind of like pi. Pi is 3.1415 something something something. Okay? So if you want to know what pi is, it is this symbol right here. Do you see that? So if you hit second pi, enter, do you see how that's just a number? A pi is just a number. Well, Euler's is just a number. And it's right here. See that E? Okay? There's that E. All right. So don't treat it as some math voodoo stuff, guys. It is very similar to pi in that it is an irrational number that in this case is the location of the asymptote of compounding anything exponentially. We call it E so that we don't have to call it that limit for compounding interest continuously. Math people love to shorthand. That would get annoying. Okay, so we call it E instead of calling the limit. So, for example, this E right here. So second E, we're going to raise it to the first power. It's this number, 2.718281828, and it's just a random number that's irrational. It doesn't stop. It just keeps going. We're limited by space on our calculator. So E is the same as 2.718281828, continued, so forth. Kind of like a pie. That's all an E is. And later on, you're going to learn it's called natural log. Okay? Whoop, sorry, guys. All right, so what is an Euler's number? An Euler's number is the letter E equals 2.718281828 something something something. And the formula for that is this. All right, so you guys are going to look at that and go, what? Well, here's a formula that might make more sense to you. See this? Instead of Y, the amount that you end up with, lowercase e is the same as your P, which is your principal. Okay? So this is the amount you start off with. E is the mathematical constant E, Euler's number. R is your rate, and time in years. So you have learned Y equals A, 1 plus or minus R raised to the X. This is your basic exponential formula. You also learned Y equals A, 1 plus or minus R divided by N raised to the N times T. This is your compounded. And today you're going to learn Y equals A times E, Euler's number, raised to the RT. And this just means it's compounded continuously. Know these three words and know which formula to use for which one. All right. Now the thing with this one is, instead of writing it Y equals that, they replace the Y with an A, the original amount with a P because it's principal, Euler's number, R times T. Same thing. These two are the same. Okay? All right. So let's take a look at an example. So how would you go about doing this? Here's the scenario 6. Your A is the final amount. Your P is your principal. That's the amount. There's your Euler's number. Your R is your rate in decimals, and your T is your time. Okay? All right. A bank tells you they will let you invest $5,000. So your P is $5,000 at 3% annually. But they will give you interest payment, keyword, continuously. It didn't say quarterly. It didn't say yearly. It says continuously. How much money will you have after 1 year, 5 years, 10 years, respectively? So let's go ahead and write the equation first. How much? My final, I don't know. I start off with $5,000, okay? Continuously, so I'm going to use E. I did parentheses, you don't have to. Raised to the rate of 0.03 t. Everyone see that? There's my formula, okay? You can also write it like this, without the parentheses. Same thing. All right, so for 1 year, I'm going to replace that t with 1 year, okay? Get your calculator. Let me show you how to use it. There are two places you can use the E. I'm going to zoom in real quick. The E is right here, but if you're going to raise it to a power, I would use that one. Either one is the same. All right, so here we go. Let me move this back a little bit so you can kind of see. Okay, 5,000 E. I'm going to use this one right here. So second ln, that E. See that? Okay, see how it goes up to the power for you? 0.03 times 1 year. So that amount is $5,152.27. Let's see. It says also for 5 years. So in 5 years, remember how I told you to go back up and push enter? Just backward. Put 5 over that 1. you're going to have $5,800, $809.17. Okay? How about for 10 years? Same thing. Go back to the original equation. Instead of 5, I'm going to replace it with 10. So I'm going to make $6,749.29. And that's all you got to do. Okay? So, make sure these are all formulas, and all you're doing is plugging in the formulas. Let's look at the next scenario. Scenario 7. A bank tells you they would like to invest $12,000 at 2% compounded, keyword, continuously. Compounded. The key word there is continuously, not compounded. Continuously. How much money will you have in 20 years? So there's your T. So in 20 years, I start off with $12,000. Don't put commas when you're writing the equation. Just count your zeros. Continuously, so there's your E, at 2% for 20 years. See, I just typed that in. So 12,000, second E, raised to the 0.02 times 20. Okay, enter. So you will have $17,901.90. Not bad for 20 years, and all you did was let it sit there at 2%. Alright, scenario 8. A bank tells you they want to invest $10,000 at that interest rate of 6%, keyword, continuously. How much will you have in 15 years? Okay, so we have 15 years starting at 10,000. Notice I leave a little space instead. E, because it says continuously, at 6% for 15 years. Alright, let me clear this. 10,000. Second E, raised to the 0.06 times 15 years. So how much money am I going to have? $24,596.03 in 15 years. Okay? Alright. A bank tells you that they will let you invest $7,500 at 7.5%, which is 0.075 if you put that over 100. Keyword, continuously. How much money will you have in 7.5 years? So, in 7.5 years, I start off with 7,500. I must like that number. E, continuously, raised to the 0.075 for 7.5 years. Okay? So let's see how much that will be. Remember, I'm a big stickler for labeling. Don't forget your dollar signs. 7,500. Second natural, the letter E, 0.075 times 7.5. Just a decimal, guys. Don't be scared. $13,162.91. Okay? Notice I just plugged into the formula. Alright. Obviously, money is not the only thing that compounds continuously. Most things, if we think about it, will decay or grow. Okay? Your body's growing continuously. And then when you get to my age, you start to decay. Alright. For example, when we talk about cities' growth over time, don't people move in and out throughout the year? When we say they are growing at a certain rate, it is based on an entire year's worth of constant change, which makes it better to use our continuous growth formula to get an accurate prediction. So here's an example. A town has been losing population consistently for 20 years. Suppose they started with 120,000 people, but they are losing around 2% each year. Assuming continuous decay, how many people do they have now? Well, let's take a look. How many people? We start off with 120,000, okay? Continuously, keyword again, continuously, I'm losing. So instead of positive, it's negative 0.02. Did you guys see that negative? Why? Because I'm losing population. It's decaying. And I want to know how many people I'm going to have in 20 years. So So I plug that in. Notice the negative. Okay? And you type it in just like this. Ready? Oh, let me see if you can see better. So, 120,000. Second E, continuously decaying. Negative. Negative. Not minus. Negative. Right here. 0.02 times 20 years. So, in 20 years, how many people are they going to have? 80,438 people. We do not have half of a person, guys. Okay? Even if you don't have arms and legs, you're still one whole person. So that's how many people we're going to have left after 20 years. All right. Let's look at another scenario. Last one, just to make sure you guys understand. Warthogs are decreasing in population at 6% continuously. See how the word keeps coming up? If there are currently 20,000 in the wild, how many can we expect to be in 10 years? Okay? All right, so let's start off with that first part of the equation. 10 years. I start off with 20,000, decreasing at 6% for 10 years. So how many warthogs are we expecting to find? All right, type it in. Negative 0.06 times 10 years. You are going to have 10,976 warthogs. Oops. Make sure I can spell. Obviously I can't. If nothing changes, when will there be less than 1,000? So this is part A, part B. So I have 1,000. Okay, I want to be less than 1,000. Okay, and I start off at 20,000, decreasing at 0.6, and the question says, when? See that word? When is a measure of time, so I got T. Alright, just like we've done before in our other assignments, you can plug this into your calculator. Okay, plug in the Y equal and look for that Y. Got it? Just like we've done before. Next unit, you're going to learn how to solve, but for right now, that's all you got to do. Okay, I'm going to clear that. 20,000. Second E, see how you just type it just the same way? Raised to negative point. Oops, I did too many. There we go. Negative 0.06 x. I don't have a T here. Okay, the T doesn't pop up even though there's a T. All right, see how I just typed that in? Now, you're more than welcome to graph, but I'm going to go to table and I'm going to look for 1,000. Notice it keeps going down because it's decaying. I want to be less than 1,000. This is the long way to do it, and it only gives you an estimate. Next unit, you're going to find exact answer by solving. Okay? Oh, I went too far. Alright, so I have two answers. One of them is, and this is in years. So one of the answers is 49 years, and it's 1,057 warthogs. In 50 years, it is 995 warthogs. And the question says, when will there be what? Keyword, less than 1,000. So which one is your correct answer? 50 years. Because 49 years, you're not at 1,000. You're still above it. Okay? All right. So there's your assignment for 4-4, continuous growth and decay. Okay? It should not take you long. You guys should be able to do this just fine. Have a great day.